guys.
Would you like the mic?
Oh, sure. Oh, I don't want to see you. Is that on? Alright. Does it sound like it's on?
Yeah, I think it is.
Is it on?
Talking to it.
Can you guys hear me through this? No?
Talking to it.
Hello, hello, test,
Alright,
test.
push the button.
This front one, right? Is that good?
There we
now
go.
I can
There
tell.
we go.
Okay. So go ahead and put your study guides away. I don't want you guys to be worrying about that while we're going through our lesson today. Today I'm going to be teaching you the very last part of your unit to prepare you for your test tomorrow, and that is finding the surface area of prisms and pyramids. And this lesson is really great because it should be really easy for you guys because it's applying what you already know. So don't be freaked out because you're going to be tested over it. It's really easy, and I'm confident that you guys will do great. One thing I wanted to point out is when I was actually researching stuff for this lesson, one thing that kept coming up on the internet was Minecraft. Does anybody play Minecraft? I know we'd have a couple fans in here. Yeah, so when I was looking up stuff, this kept coming up and I was like, what's the deal? So do you have any, I don't know how the game works, but just looking at our objective for today, what do you think that could be about?
Well, in Minecraft, you build blocks.
Right, you're building blocks. So when I looked up videos for it, especially with the pyramids, there was people building these humongous pyramids with all these little blocks. And I don't really know how the game works, but I thought it was kind of cool to apply surface area to that kind of thing. Okay, so you guys have been working a lot with two-dimensional shapes, and you kind of just started moving into three-dimensional shapes, right? So what are two-dimensional shapes? Aaron?
Shapes that just have a height and a width, no width.
Right, so they're just flat on your paper, right? They don't have any depth, and they don't stand up and you can't see them. But three-dimensional shapes have depth, right? So if I were to hold this in my hand, I saw this little triangle, this little pyramid up here before. This is three-dimensional because it has depth to it, right? And you can hold it in your hand. So surface area is applying area to a three-dimensional shape. So when I say surface area, what first comes to your mind? Any words, any equations, any numbers? Yeah. Area of one side. Okay, anything else? Can be pretty obvious, it doesn't matter. If I were to ask you to maybe solve it, what do you think what's a strategy you might use?
By figuring out the area of each side and then adding them all together.
Okay, so what I hear you saying is you're adding sides, adding areas of sides. That's good. Does anybody have anything else? Yeah? Yeah, exactly. So we're going to use our different area equations to find the areas of each side, right? So what we're going to do, just so you guys can kind of visualize this, I know this really helped me because I'm not a super good visualizer with 3D shapes. When I see a picture of it on a worksheet, I'm just kind of alright, sometimes it's kind of hard for me to kind of see when you fold it out what happens. So I'm going to pass out one of these for the two of you and start to think about how this could represent surface area. So maybe how we could use this as a tool or an aid to help us when we're trying to figure this out. So I need to take a second to talk with your partner and maybe figure out a strategy. If each side had numbers on them, maybe what's something that you could do?
Each side had numbers on them. These two,
Alright, let's share out some conversations that I hear. Who wants to say something that they were talking about in their group? Right, so we'll find the area of all the sides. So what kind of area equations would we need to know in this particular shape? Yep, length times width, because what kind of shapes are we dealing with on our flat 2D surface? What kind of shapes do you see that fold up? Are they, yeah?
Rectangles.
Rectangles, right? So we're dealing with rectangles. So why don't you go ahead and why don't you fold, just so we can see how this works, okay? So let's fold on the lines. And you should be able to fold it into, this is what's called a prism. You guys have been working with these before, so it should be no surprise, nothing new. So go ahead and fold it, just so you can start to visualize. Make sure you and your partner can both see how it's going to fold up and what this has to do with surface area. Because how is surface area different than volume? I know you guys have been doing that too. So what's the difference, Keegan? Right, so if we wanted to know the volume of this, we would be figuring out how much is like inside of it, right? But if we just want to figure out how much is on the surface area, we're just going to do the area of all the sides. So this is basically just applying what you guys already know. So this should be really easy for you. So I'm going to pass out just kind of a little like guided notes, practice pages for you. And don't write anything on it yet. Two for you. I'm just, the first few are just like a fill in the blank that I'm going to give you so you guys have something to write down so you can remember it better. So if we look at the first one, it says the blank area of a solid is the sum of all the areas of all of its faces. Does anyone have a prediction of what that could be? We've been talking about it. Yeah. Surface area. So why don't you go ahead and write that in the first blank. So the surface area of a solid is the sum of the areas of all of its faces. I think yours is under. Everybody got one? Okay. So does anybody know what this is called that I passed out to you? Do you know what we call these, Aaron?
Rectangular prism.
Yeah, it's a rectangular prism, but when it's in its two-dimensional form, we call this a net. So number 2 says, a net is a two-dimensional representation of a solid. So we can sometimes use nets to help us when we can't actually visualize the 3D shape. Alright, so this is what's called a net. And what, as I said, so number 3, you can use a net to help you find the surface area. So go ahead and fill that in, that's number 3. What kind of units do we use when we measure surface area? Do we use, is it just like meters? Is it meters cubed? Is it meters squared? Is there anybody else that hasn't said anything? Yeah?
Cubed.
Cubed? Does everyone agree with that? I see some heads up and down. I see some heads shaking no. What do we think? Well, what did you do when you used volume? We used volume when we were cubed, okay? Because what was your equation for volume? Okay, so we had length times width times height.
Or the
Right. So we had 3, if this was meters, and this was meters, we have 3 meters being multiplied by each other. So that's why we have a cubed unit when we use volume. But when we do surface area, we're just doing length times width. So what would our unit be? Yep, because it's going to be squared. Because when we find all of the areas of all the sides, we just add them together. So when we add units, that doesn't change anything about the exponent that's up here. So when we use surface area, we'll be using square units. So that's going to be the fill-in for number 4. Alright, so now I'm going to give you a few minutes, so why don't you partner up with the person that's sitting next to you, work through the problem that you see. It's the same numbers in both of the boxes, but you have a net that's drawn out for you on there, and then you have the 3D shapes. So in the table below, it's just divided up into sides. It's just kind of help you organize all your numbers. So go ahead and just find the area of each side, and then find the sum of them to find the surface area of the whole prism. So I'll give you about 5 minutes to do that with your partner. Talk about what you should do in order to figure that out.
Yeah. Build box, though.
Okay, so if you...
Yeah, basically finding out the area of
Okay, so
This is back. So you, which side would be the first one?
The bottom.
so you've done
These ones? 3 is done. Okay, whatever you want. What is the top and whatever is the bottom of the board?
What's the area?
Well, it really don't be sure enough, but it could be top, bottom, front,
So you
back,
found all
side,
the
back.
measurements in it. So just find the area of each box. Question. Question. Okay. All right, so let me draw your attention over here to the board so we can just kind of walk through this together so we're not so confused. Okay, so I'm going to try to draw this net, which it might be kind of terrible, so. So this is not to scale, clearly. Okay, so, yeah, that's terrible. I'm sorry, guys, I'm not an artist. Okay, so we have 7 inches here, 3 inches down here, 4 inches over here, and then these are all 3 because they're equal on the sides. Because if you hold up, why don't you even like look at your prism that you have here? You can kind of like start to see how this like would fold up and you'd get your sides, okay? So let's look at the first thing in the box. Yeah, question.
The last one on the end is 4.
Oh, you're so right. Good catch. Glad you're paying attention. All right, so on the top, what do we think would be the top? The good thing about this organizational tool down here is that it doesn't really matter what we put in each one because we're just going to add them together. So don't be so concerned about finding, oh, which one's the top? I have to find exactly the top. It's okay if you don't know by looking at the shape. You can just fill in the boxes as long as each box is accounted for. Okay, Keegan?
The top is 7 and 4.
Right, so we have 4, and then what would be, what's our operation? Our operation, are we adding, subtracting, multiplying, and dividing? You had 7 and 4, which is right. How do we find the area? If that's your length and your width. Multiplication, correct. So what did you get for that? 28, great. So we have, our top is 28, what? 28, what's our unit we're working with? Inches, great. Okay, so let's look at the bottom then. Well, if we know the top is 28, do you guys think that the bottom would be the same or different? We're always going to check our work, but just as a hypothesis, do you think it would be the same or different? It'd be the same. So let's work it through just to make sure, but that's something that you're going to want to look out for. There's a lot of patterns when you're solving for surface area that can save you a lot of work. So what would be the numbers that we're going to be using for the top, or the bottom, excuse me? Yep.
7 and
4 and 7 again, right. So there's 4 times 7. And that makes sense to us because if the top is 28 inches squared, then the bottom must be 28 if it's all going to fold up perfectly, right? So let's look at the front. Does anybody have any idea of what numbers we'd be using for the front? Yep. 7 and 3. Does everybody see why we did 7 and 3? I'll draw our little shape over here. Because we have a base of 7 here, and we have a height of 3, and we're finding this part right here. So that's why she said it's going to be 7 times 3. So we're finding that side. All right? So we have 21. So if our front is 21, what's the hypothesis of what our back would be? Is it going to be the same or different? Right. So if we were to just look at this other side, not this side, but if it was like on a dice and we looked at the other side, it would be, again, it would be 7 times 3 because it has the same length and the same width. What about the other side? Or on our last side? Yep. 4 times 3. So if we look at what side we're solving for here, this is 4, and we're solving for this part right here. Can't even see that with the marker, but that's what side we're solving for here. So we have 4 times 3, which is 12. Very good. So then if we want to find our last side, where's that going to be located on this prism here? Is it going to be over here? Like on that side that we can't see?
Yeah.
Right, because it's the opposite, and that's going to be the same numbers, right? So it's going to be 4 times 3. Whew, that seemed like a lot of work. So now we have all these areas of each of these shapes. Does everyone see how we did that? We solved for, let's see, 1, 2, 3, 4, 5, 6. We solved for 6 different areas of 1, 2, 3, 4, 5, 6 different shapes that are within this prism. Okay, so it's really easy because you're just doing length times width a bunch of times. The hardest part is looking at the shape and figuring out which number